Hi folks, again this is Brian, continuing on with the small engine series. We're continuing on with the way engines are built, and we're going to start out with the simpler one. We're going to start out with a two-stroke engine. The reason they call it a two-stroke engine is between power strokes there's two strokes. That means that if it comes up to the top and the spark plug fires, it pushes the piston down. That's one stroke. And when the piston comes back up again, that's the second stroke. So between the power cycles, the piston moves twice. That's why it's called two-stroke. Some people call it two-cycle. I don't like that. In other words, if they're going to call it cycle, then they'd be one cycle and two-cycle engines. That's why I like two-stroke and four-stroke. It makes more sense to me. So again, this is from Wikipedia. It's a really cool little animation they have on a two-stroke engine. Here's the spark plug. Here's the head. Here's the cylinder. Here's the crankcase. Here's the crank. This is the connecting rod. This is the piston. These are the rings. The way it works with these machines, and again, this is one of the concepts that I would like to have you stick in your head, is that science never sucks. This is all about pressure difference. Let me show you that. Out here's where the carburetor would be. The exhaust pipe would be over here. You notice the arrows. So as the piston moves up and down, top dead center, and that gets all the way to the bottom, it's called bottom dead center. When the piston comes down, you'll notice the arrows. What's happening is when that piston moves down, what it's doing is making the volume down here smaller. So it's making a high pressure. The high pressure then is pushing the gas, the air, in this case the oil, because it's a two-stroke, into the combustion chamber. And it squeezes, it's compressing, that's what they mean by compression ratio. It's compressing the gas, air, and the oil up here, usually about 9-to-1. And then you have the spark. Now here's again one of these questions I had. It's so fun, I'm in the classroom teaching. And the faster the engine is spinning, the more advanced the time needs to be. That means when this engine is sitting there and just idling, it's sparking, the spark plug is going to spark about, normally it's about 6 degrees before top dead center. And you got 360 degrees in the circle, right? So it's going to be sparking about 6 degrees. 6 degrees before top dead center. And I asked myself, why is that? The chemical reaction that's going on here, folks, is not instantaneous. It takes a while for that explosion to happen. So what they found is as the engine speeds up, and again, the snow machine engines, can even go higher than that, even higher than 8,000 RPMs, rounds per minute. It can be as high as 30 degrees before top dead center. So somewhere like in here, okay? 30 degrees before top dead center. Again, that's so that the chemical reaction inside here takes time. So that's what the reason for that, the spark, the advancement of the timing, because it makes the engine more efficient. If the engine's running 8,000 RPMs and sparked at 6 degrees before top dead center, it's just not going to run near as efficiently. So it's advancing the timing. Here is, and the holes in the cylinder here on a two-stroke are called ports. So here's the intake port, here's the exhaust port. A lot of the newer machines today too actually have a valve in the exhaust here. They have found that as the volumetric efficiency changes, in other words, as the engine changes RPMs, the engine will get rid of the exhaust a lot more efficiently if you change the size of the hole that's going to the exhaust pipe. And some are, the rave valves for the Rotax engines use pressure difference. Some of the other makes and models, I believe it's some of the Aricats, they actually have a sensor on the throttle and it's controlled electronically. So what there is in there, it's like a big guillotine that'll open and close depending on the RPM of the engine to make the engine more efficient. There's several similarities between the two-stroke and the four-stroke. Similarities being, obviously you have a head, spark plug, cylinder, crankcase, crank, rod, piston, rings. The 2 and 4-stroke share those. There are some differences. And the 4-stroke engines are more efficient.